Welcome to Level Chemistry. It is Unit 4, Day 4, and we're going to start today with a warm-up. So, our warm-up says, what is the formula for diselenium trichloride? Diselenium trichloride. Okay, so di meaning 2, tri meaning 3, so that would be selenium. The symbol is Se. The 2 for the di, chloride, and a 3. Easy as that. Same process we're going to do for the next one, which is tetra. That means 4, di meaning 2, nitrogen, so with a 4, bromine with a 2. One important thing that we want to do is make sure that we do not reduce these. So before we reduced and erased with ionic bonds, but we don't do that in a covalent bond. So it's going to stay just like that. All right, next one says carbon atoms try to make bonds. What type of bonds? It's really wanting you to know. And where can we usually find them? So I'm going to draw a carbon up here. Let's just think about this. Carbon has it definitely has 4 electrons in its valence. So that means it needs to find 4 different atoms to pair up with. So some good choices would be like a halogen, because those each have 1 electron to give up, or like hydrogen, right? So when they get together, they can bond and fulfill their octets and now everybody is full, everyone's happy, they're in their most steady state. So they'll try to make 4 bonds and are often at the center of that tetrahedral. Okay, so on this one, it's funny because this question kind of got cut off, so I'm going to move it up a little bit so we can see. Oh, that's number 5. Let's do number 4. Ionic compounds do what with their electrons? Well, they transfer their electrons. This is different than covalent molecules because they share. Sharing is caring when you're covalent. They share. So in an ionic compound, the metal will literally give away its electron to the nonmetal, but in covalent, they share. Okay, so this is the one that got cut off, number 5. It says, which one represents a tetrahedral molecule? So of these choices, B is a tetrahedral molecule. So things in group 4, such as carbon, like what we talked about before, number 3, that have 4 valence electrons, will often be at the center of these tetrahedral molecules. Okay, let's keep going. A quick reminder that if you are wanting to retake your Unit 3 exam, remember the deadline is going to be coming up on November 13th. I highly suggest that if you made less than a 75 that you consider doing a retake, because the next exam is coming up on the 18th or 19th, depending on if you're red or blue day. You need to know the material we covered last time in order to be successful on this unit. So keep that in mind. You are going to need to complete the ionic remediation exam or assignment. There is an assignment on Canvas. It's called Ionic Remediation Assignment, and any other missing work before you are cleared to retake that test. All right, so in your notes today, we are learning how to calculate a percent composition of a compound. So you're going to need a periodic table, and you're also going to need a calculator. So what is percent composition? When we're talking about compounds, it can be useful to know what elements are in the compound and how much of them we have. We can talk about how much in terms of percentages. So let's just say you have like a trail mix, right? So you want to know, is your trail mix 90% peanuts? Or is it 15% chocolate, right? You can calculate this. Right, let's just say these are, I don't know, craisins or raisins in your trail mix. So I've got 4 raisins. We'll say you have 2 pieces of chocolate and maybe 2 granola clusters, right? So you could figure out your percent composition. How much of this mix is granola? How much of it is chocolate? And how much of it are raisins, right? This is what we're doing with percent composition. Okay, so percent composition can tell you, just like we were talking about our last example with the trail mix, right? X% is chocolate, right? X% is granola, and X% is raisins. I think that's what we said. So they should all add up to 100%. You can't have some missing amount, right? So always when we're doing a percent composition, the total is going to add up to be 100. Percent composition, this is my formula for percent composition. So you might want to star this or something in your notes so you know this is your formula. Yeah, I'm going to put a star by that. This is important. It's part over whole times 100. So when I said part, remember when we had our example before, we said, oh, I'm going to go back and look how much I drew. I said, okay, I had four raisins, so that's my part, 4 raisins, 2 granolas, and 2 chocolates. To get my part, I just use these 4 is the part of the raisins, 2 is the granola, and 2 is the chocolate. The whole is all these added together. So 4 plus 2 plus 2 is equal to 8. Okay, so I'm going to go back to that other slide because, well, I could show you actually over here. So if I wanted to know my percent composition of chocolate, I would say part divided by whole, which is, again, all of them added up, which is 8, because 4 plus 2 is 8. Part over whole times 100. So in your calculator, you're going to just say 2 divided by 8 times 100. And I'm going to put that in my calculator. 2 divided by 8. So this mixture is 25% chocolate. 25%. So that's just giving you a simpler example. And in these problems, you may have to find the mass of each element and the total molar mass before you can calculate the percent composition. So once again, you're going to need the periodic table. You'll need your periodic table. Okay, here we go. Let's do an example. Let's find the percent composition of hydrogen and oxygen in water. So the mass of hydrogen, this just came from the periodic table. That's where that number came from. So if you're wondering, where's this 1.008? That's from the periodic table. So I'm going to say, I'm going to multiply that by 2. And you might be saying, well, where'd that 2 come from? The 2 came from right there. Okay, so 1.008, again, that's just from the periodic table, the average atomic mass. I'll pull that up. Look. So get your periodic table out. That's going to help you. There it is. So it came from right there. And I know that's really small, but I just wanted to show you where that number came from. Right there. So that's the average atomic mass. I'm going to multiply by 2. Once again, get your calculator out. So I'm going to say 1.008 times 2, and that is equal to 2.016 grams. 15.999 is going to be equal to, same thing, it's going to be 15.999, right? Because there's only one of them. That came from here. When there's no subscript, we understand that it's a subscript of 1. Okay, so you just got to understand that that's going to be 1 right there. It's an understood one. Okay, and the total molar mass, we're just going to add them up. So just add them together. So once again, calculator out. Oh, that's a lot of tabs. And that is 18.015. So when I added these together, I just added them together, gave me my total mass, which is 18.015. And here are these steps written a little more neatly for you. All right, so now that we have our total masses, we can do the percent composition. So the total molar mass gives us remember it was part divided by whole. So right here, these are your parts. The part that is hydrogen is this weight right here. The part that is oxygen is this weight right here. And this is your whole when we add them together. So here's a part, and there's my whole. Okay, so here is my percent composition. Once again, we said part divided by whole, part. You figured those out previously. There it is. This is my part divided by whole times 100. Part divided by whole times 100. So once we found that molar mass, it's pretty simple. So I'm going to put it into my calculator. 2.016 divided by 18.015 is equal to 0.111906, etc. But we have to multiply that by 100 times 100. So that's going to give me 11.191. And I rounded this a little because this is a very long number, so I rounded that 0 up to a 1. Okay, now we're going to do the same thing. For oxygen, the part was the mass of the oxygen that we found previously. So I'm going to say 15.999 divided by 18.015, and then I have to multiply by 100. So when you do that in your calculator, you're going to get 88.7 and I'm going to round up again, 1%. Now notice when we add those together, because you should always have 100% should be your total. So when you put both parts together, you should have 100. That's a good way to check your work, right? So I'm gonna just check my work. I'm gonna add up my hydrogen and I'm gonna add up the oxygen and make sure it equals 100. So I can say 11.191 plus 88.81. Okay, so when I added up, it gave me 100.001, and that's okay because I actually rounded a little bit. So you should be very, very, very close to 100% when you add these together. So when I added 11.191, I'm going to write it down here so it's a little more neat. 11.191 plus 88.81, it did give me nearly 100%. So I was correct. If you ever find when you add them together that is very far, let's say you added your parts together and you ended up with like 207, you know you've made a mistake somewhere. So it's a good way to check your work at the end. Okay. Here's that all filled in for you a little more neatly. Okay, the next problem says aluminum oxide. Find the percent composition of Al and O in this compound. First thing we have to do, it just says aluminum oxide. We don't have a formula, we just have a name. So what we're first going to do is find our formula. It's a 4-step formula. Step 1, symbols. So I've got aluminum. It has a +3 charge. Remember, that's why we said you have to learn those ionic compounds because we're using them again this time. Oxygen. It's got a -2 charge. They are going to crisscross. All right, so now I know I've got 2 aluminums. I got that from my formula. And this is multiplied by the mass of aluminum. That came from the periodic table. Okay, so I'm going to say 26.982 times 2. Okay, I'm going to put that in my calculator. 26.982 times 2. Okay, that gave me 53.964 grams. 53.964, and I'm going to multiply the mass of the oxygen, again from the periodic table, by 3, because that's what I figured out in my formula. So that's 15.999 times 3, and that equals 47.997 grams. So to get the total molar mass, okay, of the aluminum oxide, so total molar mass of Al2O3, I just add these. So I'm going to take these two and add them together. So 53.964 plus 47.997 is equal to 101.961. So 101.961. Once again, I'll say it because that is not very neat. It is 101.961 grams per mole. Okay. There it is. More neat. And again, I just added them together at the end. So this was adding. I just added these two. This gives me my part, just like before. Remember how we said part and whole? This is my part for aluminum. This is my part that is oxygen. And this is my whole. So it's part divided by whole times 100. There. So I've got my part divided by my whole times 100. And I did the same for oxygen. That gives me 52.93% is aluminum. And the percentage that is oxygen, when I take 47.997 divided by the whole, and then multiply by 100, the answer is 47.07% is oxygen. You're not going to find the total. You should. This is just really, this part down here is just a way you can kind of check yourself, because your total should always equal about 100, right? Total at the end. But your questions on your test will usually be stated as, what percentage is aluminum, right? In this case, the aluminum is about 53%. And then it'll say what percentage is oxygen. The oxygen is about 47.07%. This part down here is more of a way to check yourself, because it should equal 100% when you add these together. So you can check yourself and say, oh, if you find that you have some crazy number and it's 200 or 300 or 50, then you know you've made a mistake. Okay, because when you add your parts together, they should always equal 100%. And there's how I checked myself. Okay, just a quick review before we go with this unit, because this is our we are going to have a review next class, but this is our last part of our notes. Just to quickly review, ionic bonds involve the transfer of electrons from a metal to a nonmetal. They are insulators as solids, and they have high melting and boiling points. This makes these substances very hard and very brittle. Covalent bonds involve a sharing. So I say sharing is caring. So this is key. Some key differences, okay? Sharing versus transfer. And remember, the other key thing is that ionic bonds have a metal and a nonmetal. Covalent bonds are only nonmetals. Okay? They are only nonmetals. So covalent bonds have similar properties as nonmetals because that's what they're made of. So you'll find that they're good insulators in any state. They have good low melting and boiling points, and this makes them hard and brittle. So ionic bonds are also hard and brittle, but they have high melting points and high boiling points. Okay. Metallic bonds, we describe these as having delocalized sea of electrons, and it's only in metals. As you can imagine, something that's a metal is going to be a good conductor. All right, they have low melting points, high boiling points, and this bond makes substances malleable and ductile. So these have exact same properties as metals. Okay, so a quick review of your flow chart, the way you can think about naming. Ask yourself these questions. First of all, is it a binary compound? Yes. Okay. Of course, these are going to be. This is your for naming binary. It's just saying we're assuming here. You're going to be talking about ionic. Okay. So when you're looking at ionic bonds, remember we have special rules. For these. Okay, so if there is a metal, it is definitely ionic. If it has a metal, it's ionic. If there is no metal, it's covalent. If there's no metal at all, it's covalent. And then you're going to use those prefixes. If that metal has more than one cation, basically, is your metal Does your metal, is it a transition metal? That's what that means, transitional. More than one cation, that means is it a transitional metal? If it is, you should use those Roman numerals. If it's not, you're just going to use the charges. There are no metals again. There's no metals at all. It's covalent. So we're going to go through the rest of our lesson in the next few Nearpod slides.